Hello class, these are our notes for sections 3-6, squares and square roots. This is Algebra 2. So first we're going to look at solving x squared equals a, which means we have y equals x squared parent graph, and that is the quadratic. So parabolas, we always talk about how in this case my vertex, pen is not working. There we go, just had to wake it up. In this case, our vertex is 0, 0 for our parent function. We know that quadratics are parabolas, so they have that U shape. And we like to talk about how the graphing pattern is 1, 3, 5, 7. So that means from this first point, I'm going to go up 1 and then over 1 to the right. And then from that point, I'm going to count up 3 over 1 to the right. And if I was going to keep going, I would count up 1, 2, 3, 4, 5, and then over 1 to the right. So that's where the 1, 3, 5, 7 comes from. The points on the other side of my parabola are going to be symmetrical, right? I could draw a line, that axis of symmetry down the middle, and all of the points would match up when I folded it. So, solving using our graph. One can always use a graph to solve an equation. For example, to solve x squared equals 3, what we would do is we would look at the graph y equals x squared and then check to see where y equals 3. Or even better, draw y equals x squared and y equals 3 and see where they cross. So let's go ahead and draw that in. So y equals 3 would be my horizontal line that crosses my y-axis at 3. I've got a dog jumping up to keep me company here. All right, looking at the graph of x squared equals 3, here's our solutions, right? So our solutions would be where they cross, right here and right here. So it looks pretty close to 2, but not quite 2. I'm going to guess 1.7 and negative 1.7. And it is just a guess, right? It's really hard to tell when you're looking at a decimal solution, especially by a graph. We could solve algebraically by taking the square root of both sides. So let's think back to x squared equals 3, right? And taking a square root on both sides. Note that this will often result in two answers, x equals negative square root of a and x equals positive square root of a. All right, so if a is something that is positive, that means if a is greater than 0, then we'll get two solutions. If a is equal to 0, there's just one solution. So think about how if I have x squared equals 0 and I square root both sides, the square root of 0 is just 0. I don't have a plus or minus 0. It's just 0. So if it's 0, there's one solution. But if it's positive, I could have two. If it's negative, there are no solutions. And so let's think here about how negative really means that a is less than 0. We've got a couple to solve at the bottom here. So if x squared equals 16, let's go ahead and square root both sides. When I have a square and a root, let's remember that that means the absolute value of x. Square root of 16 is just 4. So a little bit of review over here. If I have x squared and I take a square root, that is an absolute value. The way I get rid of an absolute value is by trading it in for two answers, plus and minus. So absolute value is our distance from 0 on a number line. And so if I think about the absolute value of 5, that's 5 away from 0. Absolute value of negative 5 is still 5 away from 0. So we get the plus or minus. If I have just a square root of x, and then I square it, that gives me just x by itself. So if it's the square root first, it had to be something positive to be inside the square root, so it's only going to give you a positive answer. So it's different if we start out with a square versus a root. Continuing on this problem, to get rid of my absolute value signs, I write that x equals plus or minus 4. Next one is going to be the same steps, right? So we start out here with an x squared equals 5, so we're going to go ahead and square root both sides. When I have a square first and then a root, that's my absolute value. And that means x is going to equal a plus or minus root 5. Next one, I go to take a square root on both sides and can't square root a negative, so there's going to be no real solution. You can just write no solution for now, that's fine. In fact, people asked about that in class. So next we're going to solve the square root of x, and we're looking at that square root of x parent graph. Excuse me. So it says quadratic right here, but we really need to write square root. But square roots and quadratics are inverses. So if I think about how my quadratic graph was like this, my square root graph is kind of like this. Except because we can't have a negative or positive answer, we can only have a positive answer. This, you know what, I wanted just half of it to go away. So because I can only have a positive and negative answer, this half is going to go away. But it's the same graphing pattern, just on its side now. So I'm going to start it at 0, 0. And here's my 1, and here's my 3. So this time I went 1 to the right, up 1, 3 to the right, up 1. So I did the inverse, right? I kind of flipped it around. And that's going to be my square root graph. So we're looking at the graph of y equals square root of x, and we want to solve that the square root of x equals 1.5. So we're looking for the graphs of y equals root x and y equals 1.5 cross. So here's about 1.5 right here. And there's the graph of y equals 1.5. I don't know why I made it dotted. I didn't really need to. So it looks like they cross about here. It looks like a little bit less than 2.5. Maybe 2.3 or 2.2. I'm going to go ahead and call it 2.3. Solve algebraically by squaring both sides. So if I square both sides to get an answer instead, and we're not doing an arrow over, we're showing our work vertically, then x would be 1.5 times 1.5, which is 2.25. So again, I'm not going to get a real accurate kind of thing off the graph, but it's nice to look at the graph and be able to tell that your answer makes sense. Number of solutions. So if I have 0 or a positive number over here for a, I'm going to have just one solution. So let's think about how if square root of x equals like 4, or if square root of x equals 0. I can square both sides. I'm just going to get one answer. Things are going to work out. So if we have 0 or positive, and the way I would write 0 or positive is I would write a greater than or equal to 0. Now, if I have the square root of x equal to a negative number, say like -5, that's where I run into issues. I can't have square roots equal to negative. So if a is less than 0, that means if a is negative, the equation has no solution. So I really like to write in, instead of just a less than 0, I like to write in what that means above it. I think we're trying to build that language math connection in our brains. Oops, no idea what just happened there. All right, we have 3 at the bottom to solve. So let's go ahead and square both sides. And square root squared is just x by itself. So let's remember, when we have an x squared and then a square root, it's the absolute value, the two answers situation, because I could square a negative or a positive. If I have a square root first, there can only be one positive thing, and then I square it, it's still positive. So that's just going to be x by itself. So these aren't going to be plus or minus answers. So 0 squared is just 0, x equals 0. And that works. Square root of 0 equals 0. Check. All right, on the next one, we want to square both sides, and then we would get x equals 4. But let's look at what happens when we plug that back in and we substitute for x. So let's do an answer check on this one. The square root of 4, does that equal -2? And it does not. It does not equal. And that's because, let's remember, again, we had a square root equal to a negative at the first step. So this is actually going to be an extraneous solution. X can't be 4. There is going to be no solution. So when you're solving, if you have a square root equal to a negative, right away you could just write no solution. It is good, though, with square roots to go back and check every single time. All right, on the next one, we're going to go ahead and square both sides. So we have x equals 16. Let's do a quick check. Square root of 16, does that equal 4? Yes, we're good to go again. All right, and on to the next page, last page. When to use plus or minus in front of a square root. Let's see. I've got this page of like extra notes of things I want to make sure to show you. So you get two solutions in the form of a positive and negative square root when solving equations of the form x squared equals a when a is positive. So I'm going to write a greater than 0, and then I'm going to write positive up here. Whenever the square root is already given, it's already given as either the negative or positive root, and as such, we'll always have one solution. So this is saying, like, if there's x squared, there's 2. If there's square root of x, there's 1. That's kind of what they're getting at here. So just what I said. So if we have the x squared, and then to solve we take a square root, there's two solutions because we have an absolute value. When we have a square root of x, we solve by squaring. Square root had to be positive already. When I square it, still positive. One solution. So let's go ahead and compare and do some answer checking here. So when we have x squared equals 25, we're going to go ahead and square root both sides. A square and a root means an absolute value of x equals 5, and so x is plus or minus 5. And those both check out. If I take 5 and square it, I get 25. If I take the quantity negative 5 and square it, I also get 25. So two answers. On the next one, it just says square root of 25 by itself. So there's no x there. I'm just going to evaluate this. Square root of 25 is just 5. On the next one, the square root of 25 is still 5, but now I have a minus out in front. So it's going to be a negative 5. The third one, we want to know what the square root of negative 25 is, and that's back to just the no real solution thing. We can't do this. And again, you could just write no solution. I don't expect you to know when it's imaginary and when it's not yet. So you're going to go ahead and try the ones at the bottom. Show your work vertically. So kind of ignore this part right here. So go ahead and show your work vertically for these 4, and then unpause and go through and check your answers. All right, for the check your understanding, first one should be 4. Second one, we should have square rooted both sides. So the absolute value of x is 4. X is going to be plus or minus 4. The next one, you had to square both sides. But because the square root was first, there's only one answer, just x is 16. Last one, we could go through and we could square both sides and we could get an answer, x equals 16. But remember, it doesn't work in the original problem. So this was that case of the square root equal to a negative to start out with. So there is no solution. 16 is going to be extraneous. And there is no solution. So not a lot of new stuff today. We've kind of looked at solving all along and have been thinking about this. It's just we're formalizing it this time. The big thing is when we get 2 answers, when we get 1 answer. So be really careful as you solve. They're going to be all mixed together. And as always, if you need help, please make sure you ask.